Chapter 4, The Electronic Structure of Atoms, Part 3. Part 3, Electron Configuration of Atoms. Contents: Electron configuration of atoms, the diagonal rule, table of electron configuration of elements using diagonal rule, let's fill electrons in orbitals, spin property of electrons, rules to fill atomic orbitals. Electron configuration of atoms. The basic rule to assign electrons to atoms is that electrons should occupy the lowest energy states possible. As the energy level number increases, the energy of the electron on that levels also increases. For atoms with more than one electron, however, this is not always the case. The order of increasing energy is as follows: S, P, D, F. Therefore, a 5p electron has less energy than a 5d and more energy than 5s electron. When we have assigned all the electrons to a particular atom, the next atom will repeat the electron configuration and then add a new electron. This is known as the Aufbau building up principle. The diagonal rule. To determine the relative energies of sublevels, we will make use of technique known as the diagonal rule as following. The rule is simple. Begin at the left and follow each arrow from tail to head and then work from left to right. Table of electron configuration of elements using diagonal rule from hydrogen to boron. Table of electron configuration of elements using diagonal rule from carbon to neon. Table of electron configuration of elements using diagonal rule from sodium to phosphorus. Table of electron configuration of elements using diagonal rule from sulfur to calcium. Let's fill electrons in orbitals. Any orbital can accommodate 0, 1 and 2 electrons and it is called empty, half-filled and filled. Since S sublevel can accommodate 2 electrons and P sublevel can accommodate maximum of 6 electrons, as follows that a P sublevel has 3p orbitals. Similarly, a D sublevel has 5d orbitals and can accommodate 10 electrons. F sublevel has 7f orbitals and can accommodate 14 electrons. It doesn't matter where the sublevel is located, the rule is same. We will indicate the orbitals on a sublevel by using a series of dashes as follows. When an orbital is empty, we indicate this by only a dash. When an orbital is half-filled, we indicate this by one spin. When an orbital is filled, means 2 electrons, we indicate this by 2 spin. This notation shows that the electron spins have been paired and it is the most stable condition for electrons in that orbital. Spin property of electrons. Electron possess a property known as spin. There are only 2 spin states for an electron and we indicate this by vertical arrows. These designations are completely arbitrary. We can use any other pair of matched symbol. Rules to fill atomic orbitals. When we fill electrons for carbon atom C, we notice that the second 2p electron does not fill the first orbital. It half fills the second p orbitals and same pattern is repeated in nitrogen atom N. This is because electrons repel each other and will occupy whichever positions are furthest from each other. When we fill oxygen atom, the last p electron has no choice except to enter and fill the first orbital. This is the rule. Electron entering a sublevel with half fill the orbitals in the sublevel before they filling it completely.